Welcome back to the live stream. I figured I'd take a quick lunchtime break to actually start building the Z-axis on the VORON 350. So if you've been following along so far, we built the frame and then we set up a second video. That was part one. And then the second video was actually making sure the frame is straight and stable. And so now we've got everything aligned. I went ahead and I took this into the kitchen where I've got granite countertops, made sure everything was completely stable, bed level, all that stuff. So we should be in a good spot. Got to turn down my audio on this. So we should be in a good spot to go ahead and build the Z-axis. Now, a couple things I'm going to point out here, and I'll cover these in a later live stream, but a lot of these 3D printed pieces use heat set inserts. And I was actually a little bit nervous about doing these. I don't know why. They're super simple. But basically what it does is you take soldering iron, and the LDO kit at least has this additional brass tip, which is really handy because this just goes right into your soldering iron. And this brass tip is set up so that these heat set inserts, which are here in this bag, just drop in place on there. I don't know if you can see that. They just drop in place there. You heat this up, you heat up the soldering iron to, in this case, the melting point of ABS is around 220 degrees. You don't want it too hot. And then you just simply press these into the screw holes so it has a nice brass insert for it to kind of grab onto when you put the bolts in. The other thing I'll mention is that at the same time I've been doing this, I started printing out these handy guides, and actually a pair just finished on the printer back here. So I got the Prusa working overtime to make some of these jigs. And I think these are going to make the process a lot easier. So what these jigs do is they're going to snap on here, and then they have this center section so that you can sort of hold the Z-axis on here, the linear rails. And then the other piece that's really handy, well, it will be later at least, is for the motors. This can help you with spacing. So depending on which part of the project or which part of the build you're doing, it'll help you space and provide the correct placement of the pinion gears and everything else that go on the motors. So kind of vital pieces that you're going to want to print. Apart from that, I've got everything sort of set aside here and laid out nicely. I'm going to do that in all the parts going forward. I'm going to go through and actually organize the pieces before I live stream so that you're not sitting here waiting on me to do that. So this is one of the linear rails for the LDO motors kit. And I've got to say, this is really high quality. The bearings feel amazing on this. And unlike some of the other kits I've seen, the carriage on here doesn't just slide off the side. They actually have these nice bump stops for it, which is great because one of the assembly instructions is to make sure that these don't fall off because they can get damaged. But at least with the LDO kit, that just simply can't happen because of the way it's constructed. So generally speaking, and again, this is where these guides are going to come into place. These are going to go on just like this, right? So now our job is going to be to start actually following the directions. So I'm going to go ahead and pull this up. I've got, all right, the linear rails preparation. It says to make sure you get the oil off of them. These don't have any oil. I think these roller bearings on here are really high quality. So your mileage may vary on that front. All right. It says that, so per the instructions on this, rather than putting a screw into every single hole, you're going to go every other hole, which makes sense. Let's go ahead and get this going. So we're going to need a couple things for this. We're going to need the M3 machine nuts. Here we go. Machine screws. Pull some of these out. And then we're also going to need, I'm going to just raise my desk a little bit here. All right. And then we're also going to need these T-nuts, and we're going to need the M3s. These are the M5s. Should have the M3s right here. Yep. This actually seems like it's going to be rather difficult for this to slide in here. Let's see. Mind the carriage. Ah, these actually don't slide. That's pretty nifty. Okay, so I haven't seen this before. These have, and the engineering that goes into all these little pieces. So these have a little ball bearing at the back. And what that does is it applies outward pressure. So when you actually snap one of these in to the rail, you press back a little bit, and then that ball bearing applies enough force, enough friction to the back where you can position these and they don't slip and slide. That's brilliant. How cool. Learn something new every day. So now I'm going to go ahead and start assembling this. Now we need a total of, let's see, 1, 2, 3, 4, 5, 6, 7, 8. We need a total of 8 of these on each rail. So we'll just start by snapping these in. It's going to take a minute. It's so cool. Two, three, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. I know I counted it once, but what I've learned in life, I mean, it's kind of the old adage, like, you know, measure twice, cut once, right? In this case, I'm going to count a couple times to make sure I've got the right number. Then, once we do, we've got to generally get these into at least kind of the right location. Doesn't have to be perfect, but what I'm trying to do is somewhat align the screw holes. It's just going to make my life a little bit easier. Now that's interesting because if I go based on their suggestions, these rails are actually a little bit, I don't know if they're longer or if this is just not indicating the full setup. But mine actually, let's see, 1, 2, well, let's see. I mean, what I'm thinking is this needs more than 8. I think that's what I'm getting at. So I need one. One, two, three, 4, 5, 6, 7, 8, 9, 10. We need at least 10. Go ahead and put a couple more in here. All right. Now we'll put our jig in place. Help us with alignment just a little bit. Screw number 1 is in place. Might be easier to not use the jig at first. So I think the way the jig is going to really help out is once we get to a point where we're actually tightening these down. But for now, I'm just, it's finger tight. You barely want to get these going. Getting everything aligned is more the key that I'm going after. There we go. Making progress. And with anything, you're just kind of checking as you go. So I'm going to use this screwdriver to get better alignment of the holes as I go up. Seems to be working well. Alignment doesn't need to be perfect, but it needs to be close enough for when we start threading the screws in, they'll actually go where you want them to. And this little screwdriver that came with the kit is perfect for that. So we'll just continue going up. And all of the directions for this section of the kit, at least, it's do everything times 4. So you're going to do this, and then obviously there's an actual Z-axis motor at every corner of this. So it's going to keep this bed nice and level as things are moving up and down. Making progress, making progress. Hope everybody's Monday's off to a good start. I haven't even had my coffee today. I actually just made it. It's like lunchtime, and I'm just having my coffee, so I'm a little bit behind today, but that's all right. Figured it'd be nice to jump in here during lunch, live stream a little bit of the build, hopefully not break things too much. It's always the plan, right? All right, check that out. So that's pretty good. What we're going to do, I'm just going to tighten these down enough to where the rail can move. Because if they're not sunk just below the surface, then there goes my Allen wrench, then the linear rail can't move. I mean, again, I'm really impressed with the quality of these linear rails. That's crazy. And then, like I said, this jig is just going to help us keep everything nice and centered. So that's rail number 1. So it's interesting. So it says leave a gap between the bottom of the printer and the frame, or the bottom of the rail, I should say. So you can see this can slide up and down. So it recommends 3 millimeters. Now I'm going to go ahead and grab my handy dandy ruler over here. I'm going to find 3 millimeters. I was hoping that that would be about the thickness of this spacer that I've got for this jig. And it is. So I'm going to go ahead and just set this in here and slide it down. Now, at least by me using this for every single corner, they should be uniform in their distance from the bottom. Because the last thing you want is for these rails to be sort of off-centered and off kilter a little bit. So now with that, I'm going to go ahead and put the jig back on so that these are centered within the rail. The height is good, everything else is good. And then we're going to go ahead and tighten these down. And I'm not going crazy. I'm going to just get the top ones, and then I'm going to start from the center out. There we go. Nice. And that is our first linear rail. Beautiful. All right, 1 down, 3 to go. Got my ever-growing trash pile behind me. At some point, I'm going to need to clean all that up. But now is not the time. All right. We get our T-nuts, and now we know we need 10 of them. 5, 6, 7, 8, 9, 10. Let's do this corner. Why not? Go ahead and slide this down. Again, these are so cool. What an easy way to make this come together. I was so worried when I saw that you had to use T-nuts inside of the frame. The first thought that went through my mind is, well, how on earth are you going to keep these stable on a vertical axis? I thought I was going to have to lay this on its side each time I put one of these axes on. But fortunately, that is not the case. Pleasantly surprised. It's a good way to start a Monday. All right, getting these in here. 1 more to go. All right, so then we've got our linear rail. This is just going to be a rinse and repeat. I'm going to use my spacer again, drop that at the bottom of the frame, set this in place, and then I'm going to take my screwdriver and just sort of align the holes for the bolts as best as I can. And this should make the next step just a little bit quicker. This is kind of one of the fun things about building something like this is you just pick up little incremental improvements in your process along the way. I mean, this is kind of life too, right? But you just kind of pick up incremental improvements to the process. And then as you implement those, each rail or each step, whatever it is going to take just a little bit less time and effort to get done. All right, let's get this top screw started. Once that's in place, the rest will be easy. We're cooking now. This one's going to go a lot quicker. So again, I'm going to start at the top and bottom just to provide some stability to the overall rail. My screw hole lines up. There we go. All right. Then we're going to go down the line. Tighten it just enough, but not too much, because we want to, again, be able to slide this after the fact. That's going to be key. So we've got to make sure that the height is adjustable so that we can line it up with this one and have that same 3 or so millimeter gap at the bottom where it would normally touch the frame. The Z-axis is one of the more complicated pieces that we've worked on so far, but I have a feeling things are only going to get more complicated as we start building the hot end and some of the electronics. But the Z-axis, the X, Y, all the axes on this are so important. I talked about this a lot with the frame as well, because if your frame isn't aligned properly, it sort of sets the entire foundation of your printer off on the wrong foot. And the same thing can be said about these different axes. So in order for these printers to achieve the kind of mind-boggling print speeds that they have, all of the components have to be built to very tight tolerances, and everything has to be aligned just right. Otherwise, you're going to have vibrations and other issues that end up causing you problems down the road. And you're going to see the effects of that with artifacting. So when you 3D print something, you're going to wonder why there's strange artifacting, offset layers, different issues as you go. And that's all going to be the result of an improper assembly for the most part. It's also why it's so important to build your own 3D printers. I never recommend anybody buys an off-the-shelf printer unless you just absolutely have to, or unless you've been in the industry and you've built enough printers, you've worked on enough 3D printers where you know what you're doing and you know the components that are going to fail. Because it makes troubleshooting things down the road so much easier. If I've never assembled a linear rail, then how will I know how to adjust it if I see some artifacting on one of my prints? So I think the fact that you have to actually take the time to learn all of these different components of the printer, and you have to take time to figure out how they all work together, that's kind of part of the magic, and it's a really good reason why you should always build your own 3D printers. And it's fun. I mean, I actually enjoy doing this stuff. I don't know about you all. This is a good time to me. It's almost like it's a meditative thing, right? It's almost like building a set of Legos. Although in my case, since I'm live streaming, I have to talk through the whole build process. 6, 7, 8, 9, 10. All right. Let's go ahead and pop in our 10 T-locks. This one is slippery. Three, 4, 5, 6, 7, 8, 9, and 10. All right. Just like before, we're going to take our jig, lay that down. So we've got our bottom bed spacing. I'll lay the rail up against this, and then we are going to align the screw holes to the best of our ability to save us a little bit of time in this next step. 2, 3, 4, 5, 6, 7. Oh, that one popped out. Haven't had that issue yet. There we go. Back in place. Let's slide it right up. Well, my screwdriver is actually getting caught on the inside of it. So there we go. That's better. Boom. All right, that looks good. So again, we'll put our jig back in place. We need to get 10 of these M3 machine screws. Allen wrench. Just a little bit off. There we go. And I actually, on the second one, I was starting at the top. I was starting at the top and bottom. That's actually a mistake. So if you go either top down or bottom up, that's better, because then if one of the screw holes isn't quite aligned, you still have a little bit of wiggle room to move the linear rail just enough to get a screwdriver in there or something else to align the hole. So, there we go. Whereas if you secured both ends, obviously, if one of the screw holes in the center was misaligned, you wouldn't be able to do anything about it. This one's off just a little bit. Third rail, one to go. Come on. Get through this. I'll be curious to see what the total build time is on this when we're done. I'm anticipating this taking at least 3 days, but I also have a day job. And so in between this, I'm gonna have to do other work. So I think it's gonna take a little bit longer just given the number of hours I can dedicate to this. Got one more. All right, there we go. Great. Make sure our spacing looks good, and then we'll tighten down. And we'll start from the center out, just like we have been. 1, 2, 3. We should have also had our jig in place. That was my mistake. Seems like everything's still nice and centered, so that's great. And the final one. There we go. All right. Beautiful. Get 10 more T-locks. We're getting close. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Hopefully there's some extras in this. The instructions on there, they use 8, but we needed 10 because I don't know if our rails are longer or the screws are positioned differently or what it is, but at any rate. 5, 6, 7, 8, 9, 10. Beautiful. All right, start dropping these in. I'm gonna set a world record on this one. Probably not. It's not about being the fastest on this, it's about precision. I want this thing to work and last for years. And that was one of the kind of design objectives when the VORON team got together, the engineers got together and they started designing what the VORON spec would be. It was, what's a printer that you can build that's relatively inexpensive, it's high quality, it's fast, and it'll print 24 hours a day with almost no maintenance. And so that was the objective that they set out with. And then fortunately, some folks like LDO Motors started pulling together the component kits that allow you to achieve that high quality and high precision. And I know I've talked a lot about LDO Motors and Matter Hackers and everybody else that had a part in this kit, but it really is important. I mean, you can definitely build a VORON for less money, right? But you're going to sacrifice some things along the way, and that might be okay. I think you have to understand where to spend money and where to save money. And so for some of the components, like if you want to save some money, you can buy one of the kits that does not have the wiring harness pre-wired, for example. That's going to save you some money. Now, that's going to cost you a lot of time. And for me, that's just not something I enjoy doing. I don't like crimping. spending hours and hours crimping wires and cables and all that stuff, but maybe that's something you do enjoy, and that's totally fine. But don't skimp on the stuff that's important, the frame, the quality of the rails, the components like that. Those are the things that really matter when it comes down to the longevity and the print quality. The other thing is this has a very large build volume, so 350 millimeters squared, just under 14 inches. And so if you have any misconfigurations in this, you're going to have all kinds of issues when you're starting to print at that size. The other problem is when you're printing stuff at that scale, all of your prints are going to be multi-day prints. You know, it's sort of like when we were building Iron Man over here. A lot of the prints would take 2-3 days. And part of that's just because, you know, my Prusa is not as fast as a CoreXY printer like this. When you start printing for that long a duration, and can you imagine if a day in you have a print failure? You ran out of filament, your filament sensor went out, you got knocked over because your bed temps weren't right, like whatever it is, you're gonna be sad. And it's gonna cost you quite a bit of money in the process, which also sucks. Filament is relatively inexpensive, but not always. And there's some crazy filaments you can print with a machine like this, including things like carbon fiber, nylon. ABS obviously is a little less exotic, but man, I've seen some of those rolls of carbon fiber filament going for, you know, like $300. It's pretty crazy. I'd be very sad if I spent $300 on filament and then my print failed halfway through. So it's inevitable too, right? You know, we all have print failures. I don't care how long you've been 3D printing for, how well dialed in your printer is. You're gonna slice something wrong. You're gonna put supports in a wonky place. You're gonna have something that you haven't maintained in your printer for 2 or 3 years. And things are gonna happen. Let's have as few of those happen as possible. I think that's the goal. I'll tell you what, with my Prusa, man, that thing is it's a workhorse. I've had it printing, I mean, it's off right now, but it was just running, printing some of these pieces. I've had that thing going for the last couple years, almost nonstop. And it's just a workhorse of a printer. All right, so we're actually done with the placement of the linear rails, at least. Now we actually have to put the bottom deck onto the printer. So to do that, I'm going to move some of these pieces. And we're going to flip this upside down. I'm going to go ahead and move this down a little bit just so we can get a better view, because we're going to be placing the bottom, the deck of this right up here, so need a little bit more space. So at this point, we really need to start deciding what the back and the front of the printer is. So I'm going to go ahead and I'm going to make the back, well, towards the back, right? I think that's going to make the most sense. Let me go ahead and grab the back plate. I believe this is the deck panel. Yep, acrylic black deck panel. We're going to grab that, and this is what we're going to install. it's got this cover over it. I don't know how much of this I actually want to take off yet. I think I'm going to have to take off the part that's going to be facing down. But let's go ahead and test fit this first. All right, perfect. So that looks good in there. Now what we need is the M5 T-nuts. So we need 4 of those, which I've got the M3s. Here's the M5s. I'm gonna grab 4 of these guys. And those are gonna slide into these cross-sectional rails we installed earlier. So I'm gonna go ahead and set that aside for a minute. Pop these in place. Beautiful. All right, so once those are in there, now it's important to have the notch to the back. All right, M5 10s. Let's see what those are right here. So we need 4 of these guys. Perfect. Okay, so we're gonna take our acrylic. What I'm gonna do is I'm gonna peel off just the side that's gonna be facing upwards. The other side of this, I'm gonna leave covered just because the last thing I want is the acrylic to get scratched while we're building this. And so throughout the rest of the process, I like to keep it covered if possible. This is not coming off as cleanly as I had hoped. It's always something, right? I figured this would be one of those, you know how you see those videos and it's like, oh man, look how satisfying that is pulling that clear cover off. This is not that. This is the opposite of that, in fact. Oh wait, got a section coming off nicely. Make sure I get this all off. Pour it right at the bottom. Lame. Oh, this is a pain. Who knew this would be one of the longest pieces of the build process? So frustrating. anyone has any tips for how to make this a little bit easier on the other 5 or 6 panels I have to do later, I'm all ears. Okay, okay. Oh. Every time it feels like you're getting a good chunk of progress going, it just rips. Hopefully this stuff doesn't scratch too easily as well. Oh man. This is not my favorite part. I thought it was going to be as a thing. I thought this was going to be so much fun. Pulling off these little pieces, and I thought it'd come off in one nice, clean, big chunk, not 45 little tiny pieces. It's all right. We're getting there. We're so close. So close. Come on. This one is ripped into about 45 different pieces. We're almost there. We're almost there. Look at that. Almost clean. Now, I'm not going to bother taking this off the other side for now, especially since that's the bottom of the printer. I think that needs probably more protection just during the build process than the top here does. Almost. This is awful. Awful. Who knew that this was going to be an ASMR channel about peeling tape off of acrylic? Probably a market for that, though. Last piece. Come on. There we go. All right, cool. Now that that is finally out of the way, you slide this in. And then what we're going to need to do is come back and align the T-nuts on the top. So we've got 4 of them in place. These need to go roughly into the center. Boom. All right. Beautiful. Now the one thing that isn't very clear to me at this point is actually how this bolts in place. So it looks like there are the DIN rails. Okay. So the DIN rails must be part of this. Looks like there's two in here, so I would hazard a guess that these are the DIN rails. Hey, Rojas. Thanks, buddy. All right, so we've got these DIN rails. These are definitely not long enough, though. The only other rails we have are these, which are the correct length. I don't believe that's what we're supposed to use at this point, though. You can shorten the DIN rails by a few millimeters. Now my assumption is that these rails on the bottom here are likely for mounting the electronics and such later. So I don't think they need to be the entire width. Now in the instructions, they're the entire width. I think that's probably for the smaller build volume printers. It's like a VORON 2.4. We're gonna go ahead and install these. I'm just gonna tighten it down, not terribly tight. All right, so just to kind of show you, so you all can see this. You take a look at the bottom here. These are the two rails. Now they're going perpendicular to the main frame rails. And now you can see what the inside of the frame looks like with that installed. And I gotta say, that looks pretty nice. So I'm gonna move the motors out of the way now. Now that there's that bottom cover on there, they're not gonna fit. And check that out. So now we've got our linear rails, we've got the bottom cover. And next up is going to be building the actual carriages, the containers that hold these motors in place. And then we're going to mount those underneath the frame at each of the four corners. And that's going to control the entire movement and motion of our Z-axis. So be sure to check back in. I'm going to do another live stream later on today, and then we're going to build that part out. In the interim, thanks so much. And please let me know if you have any questions about this build. Obviously, as you can see, I'm just kind of figuring this out as I go too. So we're in this together. Thank you all so much for watching. Happy 3D printing. We'll see you next time.